After watching this video lecture, students will be able to calculate concentration in various different ways.
So far we've been talking about solutions, and concentration is something that we should probably discuss so that we're all on the same page with respect to expressing the specific ratios or specific relationship between solvent and solute in solution. So there's multiple different ways of expressing concentration. Some are more common than others. Some of the less common ones are percent by mass or mole fraction. There's also parts per million and parts per billion, which we'll discuss a little bit later. But percent by mass is commonly seen in basically like face creams and stuff like that, acne ointments. And basically the way percent by mass is calculated is you take the mass of the solute and you divide by the mass of the solute plus the mass of the solvent and multiply by 100. So basically the mass of the solute divided by the mass of the solution times 100, and that basically gives you your percent by mass, or your mass percent. Mole fraction, we've already seen this before. It's basically the relationship between the moles of a specific substance in the solution versus the sum of all the moles of the components. So that would refer to the moles of the solvent and solute summed together. And we've already seen this before with respect to mole fractions associated with partial pressures in our gases unit. So these are just two ways of expressing concentration. There are other ways as well. The most commonly used means of expressing concentration in chemistry class are going to be either molarity or molality. Molarity is represented by a capital M. Molality is represented by a lowercase m. Please make sure that you're paying attention to those details as their calculation approach is a little bit different. So molarity is calculated by looking at moles of solute and dividing by the liters of solution. So the total volume of the solution. Molality, on the other hand, we still use moles of solute, but we divide in the mass of the solvent only, and that needs to be in kilograms. So we're not dealing with solution as our denominator when we're calculating molality. We are looking at just the mass of the solvent in kilograms. So make sure you're paying attention to those details when you're doing your calculations and considering solvent and solute differences. So the question up here asks, what is the molality of a 5.86 molar ethanol solution whose density is 0.927 grams per milliliter, assuming that you have 1 liter of solution? Okay, so they want us to calculate molality. Okay, remember molality is moles of solute over kilograms of solvent, and molarity is one of the variables that they gave us. They told us that we have 5.86 molar solution of ethanol. Okay, so basically we can utilize this information along with the volume of solution that they gave us to calculate our number of moles of solute. Okay, so basically what we're going to do there is we're going to first figure out the moles of our solute. So in this case it's ethanol. So basically 5.86 moles per liter. Okay, we're going to multiply that by our 1 liter. Liters and liters cancel, so this gives us our 5.86 moles of ethanol. Okay, so we know this value, all right? Okay, now if we basically do a simple conversion from moles of ethanol into grams of ethanol using our molar mass, okay, we get 270 grams of ethanol. So now we know the mass of the solute that is in the solution. Now, we already know the moles of our solute. That's already been established here. So now in order to calculate our molality, we need to figure out the mass of the solvent in kilograms. Okay, so now we're going to take our density and figure out the overall mass of the entire solution. So we're going to take the 1 liter that we have of our solution and convert that into milliliters, and we're going to multiply it by our density. Milliliters and milliliters are going to cancel there, and that's going to give us our total of 927 grams of solution. Okay, so now I know the total mass of my solution, and I know the mass of my solute. Okay, so in order to figure out the mass of my solvent, I'm going to take the mass of my solution and subtract out the mass of the solvent, which I've done here, which gives me 657 grams or 0.657 kilograms. I'm then going to calculate molality by plugging in the number of moles of ethanol, which is my solute, which I already calculated there, and then plugging in the mass of my solvent here. Divide these two numbers out and you get an 8.92 molar solution. Okay, so there are some inner conversions you can do given a few pieces of additional information between molarity and molality. But make sure that you guys are paying attention to the difference between these two denominators. Okay, this is volume of your total solution. This is mass of just your solvent. Okay, it's very important that you make that differentiation. So another way to express concentration is parts per million and parts per billion, as I mentioned earlier in this lecture. Parts per million and parts per billion are usually used in very, very dilute solutions. Specifically, they're typically ways that we refer to contaminants in water sources and things like that. There are certain parameters that the United States government has that indicates the basically parts per billion or parts per million of specific contaminants that can exist and still be considered safe for consumption and things of that sort. So basically, parts per million and parts per billion are very, very similar to mass percent calculations. And the only difference here is instead of multiplying by 100, we multiply by whichever factor is needed for it to be either parts per million or parts per billion. So we have our mass of our solute divided by the total mass of the solution, so mass of the solute plus mass of solvent. Okay, and in the case of parts per million, we're going to multiply that relationship between solute and mass of solution by times 10 to the 6th, and that will give us our parts per million. So it'll be some number ppm. Okay, same concept down here with parts per billion. However, in this case, we are multiplying by 10 to the 9th. So they've told us here that we have a 2.5 gram sample of groundwater, and it was found to contain 5.4 milligrams of zinc plus 2 ion. They want to know what the concentration of zinc plus 2 ion is in parts per million. Okay, so parts per million is going to be equal to the mass of our solute, okay, divided by the mass of our solution, okay, times 10 to the 6th. Okay, so in this case, the mass of the solute was given to us in milligrams, and the mass of the solution, which is the groundwater, was given to us in grams. So we need to make those two units match. So basically, we're going to go ahead and convert our milligrams into grams by moving our decimal 3 spaces to the left. So that will give us 5.4 times 10 to the negative 3rd, grams of zinc plus 2. Okay, I'm going to divide that out by the mass of our solution, okay, and multiply that by 10 to the 6th. So you're going to go ahead and plug that into your calculator, and that is going to give us 2,160 parts per million, okay, or 2.2 times 10 to the 3rd parts per million of zinc 2 plus ion. So basically the calculation that you've done here proceeds in a straightforward manner. What you need to make sure that you're paying attention to is, well, what substance is the solute, which one is the solvent or the solution. Make sure that your mass units match up, so make appropriate conversions, and make sure that you multiply by the appropriate factor. So if this was asking for parts per billion, you would have multiplied by 10 to the 9th instead of 10 to the 6th like you see here.